All right. Ladies and gentlemen, welcome to Turn Right Machine Works. My name is Keith, and we're in here at the closing lathe, and I have this Audi 2.1 5-cylinder block up on the carriage because I can. Thank you very much for all the comments and the compliments on getting on to an interesting project here. In the comments, I've had people say, hey, it'd be nice to have the HBM. Sure, but this project could be done this way in that sibling drill press, just like I did the excavator arm. This could be set up and it could be driven over there in the K&T. This is kind of my favorite choice here. One, there's like no restrictions on room. The carriage and the bed of the lathe give me an excellent way of feeding the direction. We're going to be going into the plasma cam in a second, and we're going to cut out a holding retaining plate that I modified. Yesterday I set up the steady rest, and we drilled 4 mounting holes in it over in the sibling. So we have it there, and we drew out a drawing that will incorporate the hole pattern for this flange bearing and the 4 holes in the steady rest. That will lock our thrust. There's a retainer washer I have on the other side that will hold the bearing on. There's a register there, and that will give a stationary longitudinal travel for the bar. And then there won't be any strain on the drive itself. This is just to rotate it, just as if the spindle on the sibling was rotating it, or the K&T over there. I do have to mill a couple flats, and I don't have this all in here, but I kind of stuck a bar that I had. Didn't even have to cut it off, just dressed it up. And this angle is about 10 degrees now. 25 is the max, but why not give us some room? We'll set up a couple rags here. We might have a couple tools out here. And I also took the compound off that side just so that it wasn't something that was hindering a work area. And it was a little bit in the way, I guess. All right, I just torqued this down, not to 60 pounds of torque is what we're going to be torquing the mains to bore them out. But I'm kind of playing around with the torque that's going to control my clearance on my bearings. I made these. I got 3 of them because we're going to be running 3 of them. And we're going to alternate these around using the old original caps to hold the bar. And that's what's so nice about this is there's no dialing in. The only thing that I'm going to be dialing in once I get that plate made and this all ready to assemble for the final time, and I have my positions for the tool bit to be in a bar and those done. We'll slide the bar out in the front here, and we're going to grab an indicator, and we're going to dial that line of this with the lathe bed. And the reason why we're going to do that is so that when we're traveling back and forth, that thrust bearing is not forcing any off travel in any direction. So we're going to double check just to make sure that we're parallel with the height and parallel with the side to side run on the bar itself. Other than that, we don't have to dial the bar in. We're using the original alignment to run our job, and then we'll see what we can do for some camera shots on this operation. So let's go ahead and head on into the plasma cam now and cut that plate out. Alright, we're in here at the plasma cam, and on the screen here you can see this 4-hole pattern here is for the steady rest, and this pattern up here is for the bearing with the opening in the center so that we can reach the keeper washer on the bearing, and both upper and lower supports are slotted so we can move it around and we can have some flexibility in that plate itself. Okay, let's pan over to the table, and we'll get this thing cut out. Okay, we had a little issue with our settings. Let's give it another shot. There we go. Alright, little dross, we'll knock off the back here. We'll get it cleaned up. We'll go check out the fit. Okay, we put our first square tool bit insert in the bar. Okay, of course we're going to hack that off and then blend that in. We'll roll these two set screw holes over, and I'm getting ready to put the next one in. We set it back 100 thousandths so that the face or the cutting edge is actually about 50 thousandths above center line according to the sweep from the radius of the bar. And then this set screw is actually center of the bar, and then this one leads off a ½ an inch forward so that it's a good amount of pressure up here on the front of the tool bit, because you push always on the top side of the tool bit so that your flat surface of the back of the bore is actually supporting the whole tool bit. Alright, and then on the bottom side here is the threaded end of the insert, so you can adjust it from this end right here. And of course this is sticking out. We got some corners here, we got some burrs there, and this is sticking out here. We're going to dress all that off afterwards, but setting it in so that we're square with the tool bit. We don't want any twisting action this way or that way. It's got to be square, and it's got to be leading the center line, and it's got to have the set screws pushing in the preferred place. And that's what I'm going to show you on my next one. We're only going to be putting 3 on this bar. This will do number 1 and 2, and we'll have 3 and 4, and then 5 and 6 on this one here. Okay, first we're gonna finish sharpen up the surface here. We like the big sharpums. Alright, and we'll add a little air. Quick dry. We don't have to wait around. Alright, we're going to angle this a little bit this way here because we're going to be bringing our scale in from the end. And we have a set measurement that gives us the distance in from the end we want. So then we're going to rotate it to the other side of that square holder there. Alright, and we have a pretty good line there, and we can take our flex scale and we can lay it on there, and we can just fill in the missing line right here. Alright, there we go. Alright, now we want all of our tool bits to be in line within eyeball. Eyeball meaning we have a, and this is how I normally keep things square or locate them so that we can go ahead and work on this side of the bar, and then we can roll it over and work 90 degrees off of the bar. And I use a V-block with a clamp, and I tighten that V-block and a clamp on there, and then I rotate it and hold the square off of the table edge. And then when we're ready to roll, we roll it 90 degrees, and then I square it off the bottom of the V-block, and that gives us a near perfect 90 degrees by eye and feel. Sometimes you're using the feel of setting that square against that edge. We zero with our edge, and we come on over to mid-center here. We're coming over to our line so that we can eyeball that. We can pretty much keep an eyeball on the hole we're going to put down for the insert, and then when we roll it over, we can eyeball our center line to keep the set screws going into the middle and resting center line of our tool bit within reason. We knew center was 875 because this is 1 3/4, so 875, and we wanted to come back 100,000, so we're at 775. All right, that'll be the center of our hole right there. All right, now we don't want to just come in and put a hole on a radius, especially when we're offside. If we're center of that, we can put a hole and not worry about it drifting off. But when you're rolling over the edge, you tend to lead off, or your drill tends to go towards the downhill side of where you're locating that. So I'm going to go ahead and set this up with a 4-fluted end mill, and we're going to come over and we're just going to land a flat until I have the 1/2 inch flat in the location where we want the hole to go, so that we have a square surface to go into. Okay, we're bringing this up a little bit. We've got our end mill in there. We want to leave a little bit of room for our spindle here. Okay, and it's locked the knee here. All right, and we're pretty well set right there. All right, move our handle up. All right, we're going to engage this in here so we got some control here. All right, and we are still at 0.775. And that looks like we'll have about a 1/2 inch or a little bit better landing right there. And it doesn't hurt to have a little bit, because we're going to round that surface off after we put that sleeve in there anyway. All right, 775. Okay, right there. Okay, I'm just going to come in here with a little starter drill. About like that. I'm not going to go in any farther than that. Just the start of the dimple there. Our drill bit here should be fine. All right, and we'll go ahead and lower our table down until we have clearance. Okay, we're good there. That should be adequate. All right. All right. Now we're going to go ahead and we're going to put an old reamer in here, and I think we got to go down a little bit here. I have 2 1/2-inch reamers, and I'm going in with an old one, and then I'm going in with a new one, just because I really want a nice, no clearance fit here. All right, now I'm going to slow her down because I don't like running my reamers and burning them up. Now, keep it moderate speed here. All right, let's get the debris out of the way there. All right, and we'll put a little bit of oil on here. I'm just going down and then I'm backing it up to clear the chip. I just don't want to gall the edge there at all. I want a really nice, clean finish on the hole. If you get these sleeves to fit really snug, then you never have a problem with them loosening up for their life. And you really get good action out of your tool bit, and things aren't walking around. Besides having the adjustment on it, the square holder is just like if you drilled and broached a square hole on the bar. All right. Now we have an old reamed hole. Now we're going to have a new reamed hole. This is a new reamer, and this reamer really made this one fit tight. This was a little too tight with this first hole. After I went down with a reamer on the second hole, I had good fit on my sleeve. I mean, it's barely taking anything out of there, but it does take a little bit. Okay? All right. Now we're going to go ahead and grab our sleeve. We dress the end of that so that it kind of goes down in there. I think we can just about push that in there. We're going to take a little slug here, put our spindle. We're just going to make sure that we're not pushing on any jaws. Okay, and we should be able to push that right down in there. Okay, it's not quite going in there. I don't want to put too much pressure on my spindle. I'm going to take and move this over and lightly tap that in with my mallet. And first I want to make sure that I'm square. So I'm going to take this and put it against the back there. And that looks pretty darn square. Maybe just a little tiny bit of a rotation counterclockwise. See if I can do that gingerly. Okay, don't want to do too much because it will split out that sleeve from past experience. Aha. Okay, that looks pretty good there. All right, let's get it down in there a little bit more. We're going to move over here so I can tap it down with the mallet here. I can just start to, there we go. It's at the end. All right. Looks good. All right. Now that's nice and tight. I like that. Okay, this one was a little tight, but we put a piece of 5/16 brass key stock through it and a crescent wrench on each side, so that we don't split out the sleeve. All right, because I like them tight. All right, we're looking good there. Now we can go ahead and we can take our block and we can set it square to the table. 90 degrees here. Right there. Okay. Take our tap follower, which we're just using for a pointer, and we're going to come over and we're going to center up with this line here. And that looks like it right there. Okay, we're going to come center of the bar, which is 875. We zip past it. There we go. Okay, and center of the bar, we don't have to worry too much about facing off a place to drill. And we're going to just come down here as soon as we shift speeds here. There we go. Okay, and this will be the center set screw, and then we're going to move forward a ½ inch, and then we're going to have to switch back to an end mill, and we're going to spot in a face for it. Okay, we're coming down with our pointer, so you would see where the next hole is going to be, and that would be ½ inch from here, which is actually only 3/8 of an inch back from the leading edge of the bore once that sleeve is finished off. So that's why we need to flatten out that surface right there. So we're going to set up with an end mill. Okay, all right, there we go. All right, let's lock it in. All right, we are zeroed there. We're going to lock our spindle so we can feed it. We're still on the high end. This is a carbide end mill, center cutting. And all we need to do is come down, and we're just looking for almost a round circle there. Just a touch more. We don't have to be 100%. For 80% or better, we know that we're gonna have a nice starting hole. All right, let's pull this out and get our drill bit back in here. All right, here we go. A couple quick touches there, just making sure that we're seating center. We didn't run any starter hole at all. If you have a nice flat surface, you don't always need it. The accuracy of this quarter 20 set screw coming into the center of our bit is going to be close enough. A little shorter run just because it has less material to go through. All right, drop it down again. All right, there's our second hole. Earbuds. All right, one more in and we'll dress these off, dress the bar and get it in place. All right, we got our Bridgeport cleaned up. We brought our part over here. We already blew it off, so all the chips are off of here. We're getting ready to cut these off, and I like the Sibley vise here. I can put a rag in it and we can hold things, and this is a good working height here. I think I'm going to angle this down. Now we're going to take and we're going to slice those off, and for the first time we're going to try one of these Lennox Metal Max cutoffs. and I like the back of this head here can hold this, and I'm pretty good in a safe position here to where I'm not going to come in and nick this, but I want to go as close as possible. So I'm going to put something over here just in case. I always carry roofing flashing or contractors flashing in the little squares, and it comes in real handy just to have around. And I think I'm going to wind it in here like this. And all I want is a loose sleeve here. And I'll be able to slide this over and hit the other areas as well. Okay, nothing fancy. All you want to do is just a little bit of something between your wheel and your part. Okay, this I want this to remain really nice because this is going to go through the guide bushings for the rest of its life while we're using this bar. All right. Okay, let's get some gloves here just in case I'm holding my hand where the sparks or whatever. We're choosing this blade and this area here because it's not the regular abrasive wheel. It's got the diamond edge on here, and we're looking for less dust in this neck of the woods here in our shop. So test run, just make sure everything is fine here. Okay, I'm going to come down here, and am I actually going to get that full depth? It's going to be close. All right, let's give it a shot here. All right. No casualties. I like that. Wasn't a bunch of debris coming off of the edge there. We did push it this way here. We're rolling off a little bit of paint there, but it wasn't giving us any problem. All right, let's go. We got 2 more to go here. Okay, we flipped our bar, and we're going to hit this one on this end. Now the offset actually puts this just a little bit closer to the cutter. We should have no problem going through it all the way without a roll. Okay, we knocked most of it off there. We'll get in with our little 2-inch Scotch-Brite disc there, and we'll polish those all up pretty good. Okay, this should slide over here. Okay, now we can get to the middle one here. Alright, I'm just hitting it with the flapper for right now, just kind of breaking that break edge there. And then we're going to hit it with the Scotch-Brite after that. Okay, I usually use the maroon, but I have a little finer one here in my collection, so I just want to bring a little bit of polish out on this. There we go. Okay, and the final test is to slide a bearing over it. Alright, and here's one of our bearings that we were fitting to the shaft. Okay, we got a little riser right there. Alright, let's investigate. Oh, it's on that side right there. We can see it. All right. Looks good on there. This bearing is still one of our tight ones. We haven't done any massaging on it, but we did. It fits the bar now, but it does have to be polished out on the. Okay, we got a little bit of contact there. Okay, looks like right there. There we go. We're ready to put our bar in now that we've cleaned out. After we polished it up there, we took paper and we went around it. We went ahead and took our adjustment screws out. We took a square file. We made sure that the tool bit, everything fit nice in here. And we're loaded in here with set screws. Alright, so we're going to insert this in here. And then we're going to go ahead and align the block to the lathe bed here. Now I'm using whey oil. That's what this can is. So I lubricate my ways on all the machines, and that's what I'm going to actually use for this to go through the bearings. And we'll just put that on there as we need it. We don't have these bearings tight yet. Okay, and we'll put another little dab on here. And a couple drops in there. A couple more on here. All right, I like that. Okay. We have enough of this sticking out here that we can go ahead and we can take, I believe we can probably take our Noga and we'll set it up here on the back of the ways here. Let's wipe this off. I don't know how dirty that was. Alright. And actually, we're going to want this out here farther so we have plenty of room for it to travel. Something like that. Alright. We're going to have to come around on that side so we can crank this thing back and forth. And that's what we're going to do. We're going to bring it back and forth until we get side to side. And then we're going to put it on the top or underneath here. And we're going to find out how level this is sitting on our carriage and in accordance to the ways. And if we have to, we may have to actually slip a small shim underneath there. You'll witness that as well. So that the thrust bearing we're going to be using there is in line with this, and there won't be no side motion or up and down motion off of the line bore that we're trying to do. We want it to glide as nice as possible. All right, and there we go. We're croaking our indicator. We've got our indicator set up here. We have about 15 inches of our bar setting out here. We'll just adjust it roughly here to 0. Alright, I'm going to crank the block towards you. And come right on up there. Okay, so we got like a negative 15 and 15 inches. Let me show you how I'm going to adjust that. Okay, I kind of swung the camera over here. Now, we had roughly 15 inches there between our two studs that hold down from front to back. That lineal length is 16. So we just brought our indicator tip back about an inch from this bolt over here. Now we'll go ahead and we have the front one tight, and this one here we're going to loosen up after we set this at 0 here. Okay. Now we were reading minus 15. That means that the front is towards the rear of the lathe more so than it is here. So we need to go ahead and add 15 thousandths or bring it towards us 15 thousandths at this point right here, because we're talking about equal amount of travels. So I'm going to grab my rawhide hammer and I'm going to tap the base on the back side here, and I'm going to give myself 15 thousandths of movement here. Okay, now I'm going to tighten it down, and I'm going to reset this one at 0, and let's go back to our gauge here, and we will go ahead and set this at 0. This didn't change much from that 15 because we were almost within an inch or so of this pivot point, so that's why that dial didn't move there, in case you were wondering. Okay, now I'm going to leave you the camera where it's at now, because I'm just going to hand crank this back, and we're going to go out here to the outside and witness that I'm exactly wrong. Hey, it happens. All right, let's go ahead and tap 15 exactly the other way around, and now let's roll it. Reset it. Okay, we need to go 2 more. All right, looks like we're pretty good as far as our alignment side to side. I like that. It only changes because of the pull or push on the drag, or the surface tension on that plunger. All right. Now let's go ahead and go for up and down. Okay, we got underneath there. Let's just see. You know, I'm pulling up, and I'm pushing down. All right, pretty good on 0. Let's just bump it back and forth. Okay, it does have a little bit of motion there, but not much. All right, let's roll it on down. Let's see what we got. It's like 2+ at the end. I'm not going to say that that's all sag, but probably a good part of that. Okay, but for it to move basically a thousandths, it holds that thousandths for almost halfway there. That's pretty good travel. I think I'm gonna leave it like this unless I see any problem. We're only talking about traveling the bar an inch at a time. I think we're going to be in good shape. All right, I'm going to finish tightening down all of our points and then double check this run again. That's actually pretty good for 2015 inches with the rig here that I've set up on my carriage. It's actually only 1.5 thou total, but it almost, yeah, 1.5 thou. Let's go ahead and let's get our universal joint in here. And this is going to go into the chuck here, and set that down for a minute. Okay, and now we have to go get a set screw for this. So we have a flat lined up here. All right, I'm going to grab a set screw. when you got flats, I like to rock it just slightly, making sure you get in the center of that flat. And the reason why you put flats on there so that the set screw, when it comes down in and it mushrooms the surface, which you want a good mushroom on the cut point, because that's where it's seating, and you just don't want that metal to come up and raise up into a bore. If you had a straight bore, no relief, then it would drag, that raised material would drag out of the bore. As long as the raised material is in on the flat, which never is up against the surface, you have no problem taking the thing apart. All right. Let's go ahead and pan over and start assembling the thrust bearing there. Alright, I decided to move you over here to get a better view because, one, I wanted this bearing to come over here. I got to crank the carriage over and we'll slide and we'll assemble that. The reason why I want to do that is so that this point is the closest to the end of the shaft. It's going to hold it the closest. We already know that this thing doesn't move any more than 1.5 thou and 15 inches. So I'm just going to go ahead and squirt a little bit of oil here, and we're going to bring this back to about right there. That's close enough. All right, we got a little bit of oil on our ways here, and we can slide that. This whole thing is loose here. Okay, so we're just going to kind of bring this up here and jiggle it. There we go. Okay, in the stress-free mode. Now the first thing I'm gonna do is I'm gonna lock this down too. Let me make sure. Yep. Okay. Just felt kind of funny underneath there. I think probably over the years I've got a little bend in that keeper down underneath. All right, we got that there, and here's our keeper right there. I'm actually rolling over the chuck. All right, it doesn't have to be super tight as long as it doesn't come undone, right? Okay. Okay, those are all loose. All right, I'm going to go ahead and tighten my support down to the rest here first. All right, and these are still all loose. The bearing is not, it's self-aligning, okay, but it has a little bit of firmness into the alignment on it. So you got to bring it down a little bit of attention here. You can see the faces going together. All right, now I'll go ahead and tighten this up. All right. There we go. Okay, let's go ahead and let's break this loose right here, and let's just see if we can't turn that bearing race, which I can turn the bearing race inside here, so we have no extreme force against this. All right, here we go. We're tightening that back up. All right, we're confident we have a good fit there. Let's bring it on back here, and I think we're ready to fire this off and check out our bar. Let's go ahead and we're gonna just put a little bit of oil on this side of the bearings here, back and forth. Okay, let's fire this thing off here. All right. All right, I think we're ready to start setting up a bit, and let's get going on this project.